Bismillahirrahmanirrahim. Salatu wassalam ala Rasulillah al-Kareem. So, as we discussed about the various methods of electricity generation, the solar power generation, the nuclear power, the hydro electric power, and so on, we also have to consider certain things with regards to the power generation methods. Okay, so the first thing is about the supply and demand. See, regarding the demand of electricity, one thing is very sure, that there is always a fluctuations. There are always fluctuations in the demands of electricity, and these demands sometimes they are predictable and sometimes they are less predictable. For example, there is a rise in demand in the morning, that is basically when people get up, they turn on their lights, they use the heater or toaster, whatever they like to do, but they are going to use electrical appliances, which is going to really put a load on the electrical supply. It is going to consume lots of electricity. Okay, so people can start charging their mobile phone and so on. So this is an example of a predictable demand. So this can be easily predicted, that people when they get up at the early morning, they are going to start normally what they will do at every morning. Okay, and about a less predictable example, that is how the demand of electricity can suddenly increase to various folds, multiple folds. A less predictable example is this one, that suddenly there is a demand, there is an exciting episode in the TV program, in the TV channel, and millions of people, they are glued to the TV on particular time. The viewers in front of the television, they are they decide to make a dish or a cup of coffee, tea, okay, during that program when it is being aired on the television. Okay, so this is a very good classic example of a less predictable demand in electricity. Okay, so this way the demand in electricity can fluctuate. Okay, the usage will suddenly increase due to certain situations. So it is very important that we should have important uh, plans, strategies to meet such sudden rise in demands of electricity. For that, we have to consider which generation method is best to meet certain predictable as well as unpredictable demands. Okay, so this is what we are going to discuss next. Which power generation methods are suitable for such unpredictable demands? Okay, when there is a surge of demand of electricity, which systems are the best? So number one, let's see regarding this nuclear power station. See, mostly nuclear power stations, they cannot be turned on instantly. That is, they cannot be turned on like a switch, okay, within few moments. Nuclear power station, this process, it's the starting of the fission reaction and the heating up the core of the nuclear reactor is a very lengthy process. It takes a longer period of time to generate electricity. So, clearly, nuclear power stations cannot meet sudden variations in demand. You might be knowing about the nuclear fission reaction. Nuclear fission reaction is the splitting of the atoms into two or more lighter atoms. A heavier atom, it splits into two or more lighter atoms. So when this splitting process happens, it releases massive amount of energy. This energy is used to heat water, which in turn produces steam. This steam is used to run the turbines, which further produces electricity, because these turbines, they have this huge magnets connected to it. Okay, so the end note, the conclusion is nuclear power stations, they cannot meet sudden variations in demand. Then how about fossil fuels? Yes, power stations that burn fossil fuels can be started more quickly comparatively, but can still take many hours to start producing electricity. Okay, coal fire stations take longer than oil fire stations to develop the heat required to drive the steam through the turbines, whereas the gas fire stations can respond most quickly to rises in the demand. Okay, so among the fossil fuels, gas fire stations, they respond more quickly. Okay, so point to note. How about wind and tidal power generation? See, wind power generation, it is totally depend on the strength, the direction, the frequency of the wind. Again, wind, the blow of the wind, how it will blow, the strength, the frequency, it's all unpredictable, because it's all related to the nature, to the climatic conditions. Although wind farms are located in windy areas, they cannot be relied upon to produce electricity at the times when it is needed the most. Whereas the tidal power is not available continuously, but the times at which it will be available are unpredictable. Okay, so both of these, wind and tidal power, they are pretty much good when it comes to immediate power generation. They produce electricity immediately, but they are not predictable, because they depend on the wind and the tides, which are totally, they are a natural phenomenon. Okay, so the best thing is to rely on this one, hydroelectric power stations. Okay, because they provide a very reliable energy resource, with the advantage of being able to respond very quickly to changes in the national demand for electricity. So they have this capacity to produce electricity in a very short period of time. Okay, and they are very efficient. Why? Because they are ideal for even storing large amounts of extra electrical energy. See, suppose side beside this hydroelectric power station, there might be another station, might be a nuclear powered or coal power or whatever. Okay, the extra electricity which is provided, is produced by this power station, which is next to this hydraulic power station. Okay, it will not be wasted. How we can pump this electricity uh, to pump up the water back into the high level reservoirs. We can use this electricity to pump the water back up into the high level reservoirs. This transfers the electricity, the extra electricity, back to the gravitational potential energy GP, which can then be transferred when needed at a later time. Okay, so this hydroelectric power station, it responds quickly to the demands for electricity, as well as it is an ideal system for storing large amounts of electrical energy. Okay, by using this technique, that is using the extra electricity to pour up the water to pump it back into the high level reservoirs. Okay, that is this electrical energy is converted into GPE, which can then be transferred when needed at a later time. That means if we have very quick national demand, sudden national demand for electricity, then it can be used later. Okay, we learned about the supply and demand factors. Now it's about the cost factor. Okay, so with regards to the power generation, we have to also take into consideration the cost of any power generation system. Okay, how much does it cost? That's very important. Okay, so that it gives a good benefit for whoever it is, whether the government or the private agency. So let's move ahead and learn about the cost factor. See, nuclear power stations, they use a very relatively cheap fuel. Uranium produces huge amounts of energy, so the cost of energy per unit of fuel used is very low. As I told you before, a small piece of this uranium can power up hundreds of houses for many days. A small piece, a very small piece. Okay, so that means that nuclear power generation, it's a cheap fuel. However, the building of a nuclear power station is very, very expensive because it requires complex technology and a very high standards of safety. You need to consider the safety factor. You have to keep the workers, the employees safe. You have to give them a safe environment. Okay, and you also have to protect the natural habitats, that is the environment as well. So you have to consider all these things, so that will really increase the cost. Okay, but finally, on the top of these startup cost, the planners, the agencies must also consider the expense of decommissioning. What is the meaning of decommissioning? It means closing down the facility, the nuclear power plant facility. Okay, so a nuclear power station at the end of its useful working life. Okay, so closing down and the disposal of the nuclear waste, how it is disposed, whether it is disposed safely, whether it will not cause any damage to the environment. This is a very important question, and this has to be taken into consideration, and this also is very expensive thing to do. Okay, so finally the conclusion is nuclear power generation is it's a cheap way to produce fuel. Okay, but at the same time, the construction, the installation cost is very, very expensive because it requires complex technology and requires a very high standards of safety. And finally, the decommissioning, the closing down of a nuclear power station is also very, very expensive because the disposal of waste is very, very important. The correct way of disposal. Okay, and the running costs of nuclear power are relatively low. but the payback time is very long. So what does it mean? Payback time. Payback time is how long it takes for the income from selling electricity to cover the cost of the building the power station. That is, an agency or a government agency builds a power plant for a cost of some 1 million, for example. So it will take a very longer period of time to get that 1 million back. Okay, so that is what it means, payback time. So for nuclear power station, the payback time is very, very long. Okay, now it's about the wind farm, wind power generation. See, the cost of setting up a wind farm is much lower than the cost building a nuclear power station. So relatively it is cheaper, and there are no fuel costs. Here you don't have to purchase or buy fuel like coal or uranium. You just have to set up windmills, okay, the kind of windmills which are set up for the wind farm. That's it, class. However, the amount of energy produced by wind farm is comparatively low. In no way it can be compared with the nuclear power plant station, because a nuclear power plant station, it produces a massive kind of energy, massive amount of energy, okay, which is incomparable to the energy which is produced by a wind farm. Okay, and the payback time for the wind generation is also quite long. Okay, just like nuclear power plant. Okay, so two things you have to remember. One is about the cost, and the other one is about the payback time. Okay, and finally, nuclear fusion reactor. See, presently in our contemporary world, we only have nuclear fission reactors. Okay, I think you might be knowing that there are two types of nuclear reactions. One is the nuclear fission reaction, and the other one is nuclear fusion reaction. Okay, so the power plants which we have for the generation of electricity, they are nuclear fission reactions. That is, in nuclear fission reactions, we split a heavier atom into two or multiple lighter atoms. When this splitting process happens, there is a release of a massive energy. Okay, so we tap this energy for our electricity generation. So this is fission reaction. Now what is fusion reaction? Fusion reaction is just the opposite of the process. That is, we try to fuse, that is, we try to join. Okay, so the meaning of this word fuse is to join. We try to join two lighter atoms together. When they join together, they form a more massive, that is a heavier atom, which provides us with, again, a massive nuclear power energy. Okay, so for example, this nuclear fusion reaction is now it's happening inside the sun. This is how we get energy, the heat from the sun. So it is the nuclear fusion reaction which is allowing the sun to produce heat, energy and radiation. Okay, so this nuclear fusion reaction, it's a very, very complicated process. Scientists, they are trying to mimic this kind of reaction, fusion reaction, here on our Earth, so that we get a very long-term solution to the world's demand for energy. And another very, very interesting point, interesting advantage of this nuclear fusion reaction process is that it doesn't produce nuclear waste. Okay, so we can also deal with the safety factors also in a very effective way. Okay, but as of now, a nuclear fusion reaction or a nuclear fusion reactor has not yet been built. Okay, but people are trying out, but they haven't built any one. Okay, so this is a picture of a nuclear fusion reactor. There is also another picture in your textbook as well, in the last page of your chapter 17.